So this is Sean Barbeau. I'm going to be talking about the first part of our presentation today on web-based trip planning options for transit agencies. So just a general overview of what we're going to be talking about today. We're going to be looking at the available web-based trip planning options for public transportation. We're going to talk about the importance of open data in this kind of ecosystem. We're going to talk about how to assess trip planner options depending on different circumstances, and then finally talk about an open data implementation plan. And just to give some context to today's presentation, so this presentation is based on a project that was funded by FDOT, which was the Sunrail Electronic Trip Planning Study. So Sunrail is a new rail service for Central Florida that's going to be rolling out in spring 2014. And the Florida Department of Transportation wanted more information on different options to make online trip planning services available to the potential riders of the service. And this includes both possible connections to links in Orlando and Votran and Daytona Beach, which are operated independently of Sunrail. So I think one of the first questions that a lot of people bring up when we start talking about transit trip planning is the Google Transit really all you need? And Google has definitely been a strong force in the transit trip planning world, including was behind one of the developments of one of the most heavily used formats for representing transit data, the GTFS. So we'll talk about that a little later in the presentation. So I think what we want to communicate in today's presentation is that Google is just one possible trip planner that's out there in an ecosystem that's much larger. So hopefully we'll help address this question as part of today's webinar. So we're going to get into the first part of the presentation now, which is the web-based trip planning options. So when we look at the general categories of online trip planner options, it really breaks down into three categories, and there's kind of multiple divisions under each category, but these are the three high-level areas. So the first is proprietary vendor-based solutions, and these are the commercial products that have been around in the transit agency for a while. The second area is third-party applications, and these are based on data that are openly shared by transit agencies, but the third-party applications are not directly provided by the transit agency itself. So there's really a separation between the agency and these types of applications. And Google Transit is an example of one type of third-party application. And then we get into the third category, which is really the newest area in online trip planning options, and that is open source solutions. So contrary to especially number one, the proprietary vendor-based solutions, open source solutions actually provide the source code of the software out there for anyone to use for their own purposes. And we're going to talk about one particular open source solution, Open Trip Planner, a little later in this presentation. So when we're looking at number one and number three especially, there's really breaks down into an agency can either host these services in-house or they can be hosted by third parties. And then a further distinction as well is there can be integration with different agencies, and two examples of those are with 511 systems or with other regional agencies. So with that, we're going to break down and look at these categories individually. So I'm going to turn it over to Justin at this point, and he's going to talk about the proprietary vendor-based solutions.
Okay, thank you, Sean. So yes, this is Justin, and I want to talk to you a little bit about what might be considered the history of, for a lot of people would have been considered the land before time, as you might call it, or anything before really 2005, going back about 8 years now. There were trip planners out there before Google. They were typically constituted of products provided by vendors who had developed these in response to kind of what was emerging as an opportunity, which was more web-based solutions, and therefore, how could trip planning be automated beyond what was typically previously just provided as part of customer service, maybe looking at a map, doing pen and paper work. So automating trip planning and putting it on the web before the emergence of Google Transit was done typically via these products. They were made from, or the routing engines were developed a lot of times in a kind of proprietary format, which because there were no standards at that time, the standards were developed by the vendors who created the products, and they were typically created and fed from schedule data from software packages that did scheduling for the transit agency. So because you've already kind of built up this capability at a transit agency to do automated software for scheduling, you could then use this as the basis for doing web-based trip planning, and that's exactly what happened. In the beginning, there were a limited set of options, a limited set of functionality that you could do, but it was still a far leap from what was previously being done. There were some issues with these type systems in that they were reliant on street networks that were still kind of in development. So I don't know how many of you have made extensive use of any transit trip planners, but they are you kind of take for granted the quality of the data that goes into the street networks that underlie the routing. So back then, there weren't many companies that sold or maintained this data. It was expensive to license the data. The source of some of the data came from the Postal Service, and often this information was incorrect or it needed to be kind of refined, and therefore you had potential for errors when you were getting trip plans returns. But you can still find some of these products out there. I mean, it's not to say, despite their limitations, that they weren't, pretty well utilized, and certainly it can be evidenced by some of them still being out there today. The advantages of these products, particularly for their time, were that, these were turnkey systems. Everything required some level of customization for the agency. But the vendor provided not only software but a lot of times assistance in implementing these systems. And as limited as the functionality was at the time, it was relatively high level in that you could plan a trip start to end. You could control some of the parameters about dates and times. You had the ability to choose fastest path, and some of the other things that are kind of common in today's products were emerging at that time. Some of the disadvantages that have kind of led to the legacy issues that these type systems are going away are that they are high cost to procure and maintain. I mean, these were not inexpensive systems, and particularly on the maintenance side, the amount of effort that goes into it was high to keep them up. You had some issues with vendors over time. If they don't support the product, you are locked in, and you're responsible for keeping that up. I want to launch into something that is kind of an example of a bit of a hybrid of what you could consider this self-hosted proprietary system. In that, in 2004, the Chicago RTA responded to an FTA request for a proof of concept multimodal trip planning system that offered $1 million of FTA funds to create a state-of-the-art door-to-door multimodal system. As you can see, the goals here were to integrate not just transit, but bring driving options in, walking, bicycling, rideshare into a single end-to-end trip for users. So now we're getting into this first mile and last mile issue of, not only how do I ride transit, but how do I get there and what are my options. Another goal was to use the TCIP standards that were in development at that time. There were some downsides, as I discovered through the project, is that had some of the same issues with the traditional vendor-based solution, in that they brought in a product, customized it, and kind of maintained it on their own. They still maintain it to this day. The software is not open source, and there are proprietary data formats. Here's just a look at what that interface looks like, where you can do some pretty cool things with the GoRoo Trip Planner, and this is currently supported and maintained by Chicago RTA, which incorporates here some urban and suburban bus systems and rail systems. You can input a number of different options and get some of that multimodal capability that the original trip planners did not have, that were just schedule based. Another consideration here is the cost, and there was a 2010 DOT evaluation study that was conducted that looked at some costs, and some things not really considered, I think, kind of taken for granted again today with all the options available, is that not only do you have the cost to develop and maintain the software, but you kind of need to develop and focus a user base and get some feedback on how well it's utilized. So you can see here, it's some things like search engine optimization is if that's an annual cost, I mean that's pretty high. And actually, they costed the return on investment, or actually not a return on investment, but the number of visits worked out to about 23 cents, or almost a quarter per visit over the cost of 10 years. So you have to be, if you're interested in doing this, you have to be aware of the costs involved in operating and maintaining it. Ultimately, the lessons learned that came out of that is that there were some good things to take out of this project, and that local control over the trip planner and its evolution is important if you're going to use a system like this, and that's really one of the primary advantages. You can tailor the system to meet the needs of your specific ridership base, and in a major city like Chicago with all these connecting modes, that may take precedence, and all those costs may be a value compared to what you would be dependent on outside of something you don't control. So it's definitely one of the main advantages to going this route. They were able to implement features at their own pace and discretion. Where there was feedback from the local user community in Chicago, they're able to take that feedback and turn it into functionality in the product. And that is, again, something with the third-party web-hosted systems, you are kind of beholden to the product development on its own. You'll hear more about that from Sean about open source solutions addressing that, but that's something to consider. In speaking with RTA, they said dynamic trip planning is a direction they're going, where trip plans are actually updated and dynamic in the sense that they respond to real-time conditions. So you have real-time information, which is where's the vehicle, when it's predicted to arrive, but your trip plans are static in the sense that they are schedule-based. Dynamic trip planning would, we're definitely not there yet technologically, but it's a goal of theirs, and it would respond to environmental conditions and update trip plans accordingly. And then finally, the main limitation coming out of this, and I think what was really learned is the pace of development in this sector outran what GoRoo was able to do. So therefore, you have to accept the risk if you want to go this route that your product is going to kind of sit back on technology that could become outdated quite quickly. I just briefly want to touch on integration to another method of getting transit trip planning out to your user base, and that's through 511 systems. And 511 systems, as you may be aware, historically are just it's more of a broad-based transportation information system. 511 represents the phone number to dial in most major urban areas that you can retrieve real-time information on the roadway network on things like road closures, accidents, incidents, and traffic. It stands to be that a logical extension of that would also include transit. What we found in our research is that, most places where you find good transit trip planning incorporated in 511 systems are where you have a viable alternative to personal auto travel. So if transit represents a relatively low mode share compared to auto travel, hosting it on a 511 system may not get as quite the benefit you would get as if you could literally walk out your door and make that choice in that day or within, your daily routine for commuting or otherwise, that transit would be a viable alternative to the auto. And that may be true in some places, and certainly in major urban areas that's the case. For a lot of people, and possibly a lot of people on this call, that would not really work for them. However, transit trip planning through 511 is something that's definitely done. Here are just some examples. You've got, I want to cite out the New York example there, because they also incorporate private transit carriers in that network, as well as public transit carriers. So that's a pretty powerful function, and it's got a lot of data included. You've got real-time information on the San Francisco Bay Area 511 system, and they also have a mobile application. So this may not be a good model for the majority of transit operators out there, but it's definitely something to work towards. And as the quality of transit systems and the quality of transit data gets developed, this is certainly another place to host that information. I'm going to give it over to Sean now to take you through the third-party applications and some things you may be more familiar with.
Thanks, Justin. So when we talk third-party solutions are typically based on open data. So the question is, what exactly is open data? So open data is transit data that's shared with the public, and it's typically shared via either a website or FTP site or some type of web service. And the best practice that's emerged here is that it shouldn't be behind a protected login. There's other ways to authenticate users, and you can do that via something like an API key that's unique per user of the data. So these data sources should all be updated regularly. So every time the agency changes any type of their service, in a scheduled service markup, for example, this should be reflected in the data. So any changes to schedules, routes, and stops should all appear in this open data that's shared with the public. So the question is, why is open data important? So open data allows the public to contribute services that are cost or time prohibitive for the public sector. And in the transit industry, one area where third-party developers have really stepped in have been mobile applications. So there's a large number of mobile application platforms out there, and it's really cost prohibitive for the agency to develop custom applications for each of these platforms. So if the agency is able to share their data, it allows just either the general public or private or other public agencies to step in and develop solutions that are based on that data that the agency is sharing. So another reason here why open data is important is that vendors can be unpredictable. And there was a good example of this with when the iOS 6, the new set of iPhones rolled out. So Apple made the business decision to drop Google Maps as their primary map provider. And when this happened, all the new iPhone users lost transit directions in their default map solution for about 2.5 months. So this is something that Apple openly said that they were relying on third-party apps to fill the gap of providing transit directions. But obviously, if an agency was only sharing data with Google, no third parties would actually have access to the data to be able to fill this gap. So when an agency is providing open data, it really reduces the risk that there's going to be one particular vendor that takes an action that affects a large amount of the transit customers. So open data allows for more solutions and a bigger opportunity for dissemination via different channels. So what's really become a dominating force in open data is the General Transit Feed Specification, or GTFS. So this was initially created by TriMet and Google in 2005. TriMet wanted to provide transit directions in a online map solution where at the time most of the major trip planning providers all focused on just driving directions. So Google responded to TriMet's request, and they worked together to develop this relatively simple specification, but still very powerful. It describes really the transit services that are needed, things like schedules, routes, and stop data that are needed to plan a trip from point A to point B. So on the left, you see an example screenshot of just a sample GTFS data set showing the stop locations. And the GTFS data set consists of multiple text files that are formatted similarly to this. So GTFS is currently used by transit agencies to represent their static schedule service by over 500 agencies worldwide. And that includes 49 of the top 50 largest U.S. transit agencies share their GTFS data publicly, and over 227 total in the United States. And we're aware of at least 20 Canadian transit agencies that are sharing open data as well. So in the early stages, most agencies created this GTFS data set because of Google offering their free transit trip planner to anyone who would put their data in this format. But really, GTFS has emerged to support all types of third-party applications. And as I mentioned earlier, Google Transit is just one example of a third-party solution. So there's all different types of mobile apps that rely on GTFS data to provide various types of transit services. And it's also used by Open Trip Planner and One Bus Away as well, which we'll talk about a little later in this presentation. And if you want to review which agencies are sharing their data, GTFS Data Exchange, and the URL is listed at the bottom of the presentation, is really a good place to start to see which agencies are providing their data. So just some general recommendations for creating and disseminating GTFS data, and we'll dive a little deeper into each of these recommendations later. So I'm just going to hit them at a high level at this point, just so there's a general overview. So really the first step is understanding the GTFS format. There's reference documents online to look at this specifically and understand how your data as a transit provider will fit into this format. And then secondly, determine if you're going to maintain and create GTFS data in-house or whether you're going to rely on an external organization for that service. And there's major transit software packages can export data into GTFS format. And there's are also consultants out there that you can work with. One example cost that we have seen is approximately $200 to $500 per route to help get your data into GTFS format, depending on the complexities of the route and the size of the system. Third is to create a terms of service license, and we suggest looking at examples that other agencies have provided. And again, we have some links at the bottom of the presentation, and we'll make this presentation available after the webinar so that you can come back and visit those. Fourth is to maximize exposure of your GTFS data, and we suggest sharing it via your website. There's GTFS Data Exchange that I mentioned earlier, is closest thing that we have to a central warehouse for providing data, and then regional sites as well. And then to create a relationship with developers through things like hackathons and meetups. And then finally, share a list of these third-party transit applications that are using your GTFS data with the general public. And again, we'll kind of hit these individual points a little later in the presentation. So some examples of third-party apps. So Google Transit, again, is probably one of the most widely known. Trip Planner from point A to point B has also fairly recently begun including real-time information such as service alerts or estimated arrival times if the agency is providing real-time data in addition to their GTFS schedule data. So Google Transit's available for more than 800 cities across more than 25 countries worldwide. So among the third-party apps, definitely one of the largest providers. There's also other third-party applications, and we have a link at the bottom of the screen here to another presentation that focuses more directly in listing a number of these different third-party apps. So something like Magnificent, which is seen in the upper right-hand corner, showcases a different type of use of the GTFS data. So this is not a trip planner per se in terms of telling you exactly how to get from point A to point B step by step, but instead it shows you how far you can get from a particular location given the transit service that's available. So in this particular screenshot, it's saying that within 30 minutes, these are the different areas that you can reach via public transportation. So this is really useful for somebody that's new to the area and wants to just understand what part of the cities can I explore, whether you're a visitor or you've just moved to the area when I rely on public transportation. So there are some downsides of relying on third-party apps. So the pros, again, if you share your data openly and follow some of the suggestions that we've outlined, there's been some good evidence in the industry that third-party applications will develop that use your data. But some of the downsides are really the lack of control over these services to users. So you're relying completely on a third-party service, and the third party may decide to discontinue their application at any point in time. And that would just leave the agency without a solution for that particular application. And again, a good example is the iOS 6 in transit, where iPhone users for some major transit systems in the United States really had no transit trip planner available in their default map application for about 2.5 months. And for a lot of agencies, I think relying completely on third-party apps just really leaves you open to some vulnerabilities, and you can't reliably provide service via all the different dissemination channels that are out there. And then secondly, third-party apps may not fill particular needs. So something like multimodal. So Google does have Google Transit and Google Bike, and they do provide walking directions, but they don't provide an end-to-end solution that combines like bike to bus to bike. And there's been some evidence at some deployments that by facilitating the transit trip via bike, you can actually cut down significantly on the service time, that how long it takes you to get from point A to point B. Integrating things such as car and bike sharing, you're really just relying on whatever third parties out there to implement this inside of their app, which may or may not happen. And if that's something that's critical to the agency, is to be able to showcase these different options, mobility options to your users, this is something that third-party apps may not particularly fill that need. Certain interfaces, so SMS, a text messaging interface, that's not something that's typically provided by, say, Google Transit, and that is an expense for third-party applications directly. So if an agency wants an SMS interface, there may not be third-party apps that fill that gap. And then regional integration as well. If you want tight regional integration with different partners in the area and control over how those transfers happen, that's not something you're going to get typically out of most third-party application. So depending on the priorities of your agency, you may need to supplement third-party offerings. Again, third-party applications are great to fill particular gaps, but when it really boils down to what you might need to supplement is really what do your particular riders need. So I'm going to talk about a new area in the industry right now, which is open source solutions. And this is our third category of online trip planner options. So open source software really differs from historical solutions that have been provided in the transit industry, which have been proprietary or closed source. So open source solutions provide the source code for the application out there for anyone to download and examine and modify and contribute to. So this really provides an opportunity for shared investment into a single set of software tools by anyone worldwide. And so that again differs from the proprietary closed source model, and that you're relying on a single vendor, which could go bankrupt eventually or disappear. And so with the open source solution, you're not relying on one particular source. It's out there. If one vendor goes away or one organization that's contributing to the software goes away, another one can step up and fill that gap. So most of these open source solutions in the transit world use open data and the GTFS format in particular. So there's some exciting developments that we've seen over the last few years. Today, in today's presentation, the next slides, we're going to talk about Open Trip Planner, which is a multimodal trip planner that includes an application programming interface for mobile applications and other types of apps to use this service. There's also, focusing more on real time, there's another system called One Bus Away, which has been used by MTA in New York. It's been deployed in Puget Sound in Washington, and we're actually working with the One Bus Away instance here in Tampa as part of a research project, partner with Georgia Tech. But if you want more information on One Bus Away, just contact me directly and we can talk about that. But since we're focusing on trip planning solutions, we're going to talk primarily about Open Trip Planner. So Open Trip Planner, we have the URL up here on the screen, opentripplanner.org. So the software for Open Trip Planner, the source code, is available at this URL, and anyone can download, look at it, modify it, customize it for your own particular solution. So the development for this project was spearheaded by TriMet in Portland with Open Plans as a major partner, and this started in roughly 2009 and is continuing to the present day. And so again, because it's open source, anyone can access the source code for this and contribute improvements back as well. And we've seen some examples of this in the Open Trip Planner ecosystem. And then vendors, and vendors plural here, so any number of vendors can provide installation, customization, and maintenance support. So Conveil is a new organization that was a spin out of the Open Plans organization. Is one example of a vendor that can provide customization. But because the software is open source, again, if that particular vendor doesn't work out, anyone else can step up and provide that role, including in-house if the agency actually has the in-house technical expertise to manage this type of software. So there's been a number of production OTP deployments, TriMet, which we're going to look at more specifically in the next slide, and a couple of international deployments as well as in Spain and Poland. And then we've seen a large number of tech demos as well, including one that we set up as part of our research project here in Tampa, Florida. So what we see here on this slide is a screenshot for TriMet's open trip planner-based solution. So again, TriMet's in Portland, Oregon. The primary motivation behind developing the solution was to merge separate transit and bike trip planning. So again, it's more about giving the user access to all of their options to get from point A to point B, not just assuming you're taking transit all the way from point A to point B, but allow you to bike the first leg or the first mile, and then bike the second leg, the very end of the trip, the last mile. And there's all kinds of different ways that you can configure it to allow for things like bikes on buses and whether that's allowed or not, and just really a full suite of options that focus on an end-to-end multimodal trip planning solution. So TriMet launched a beta version of this in October 2011 and then switched to Open Trip Planner as their production public-facing trip planning solution in summer of 2012. And so just as a proof that really anyone can access the software and deploy it in their own area, as part of our research project looking at open data and open source solutions, we set up our own Open Trip Planner instance here in Tampa. And so this uses data from 3 different transit agencies, including USF's Bull Runner shuttle system, which I'll talk about on the next slide here. But what you can see here is an example of the multimodal connection. So the user's biking on the first leg of this trip, and then boarding transit, which covers this next leg, and then the last leg here is again taken by bike. So this is an example of an end-to-end trip that's truly multimodal and combining bike and bus. No, sorry, the first leg, this is actually bike and then transit over here and then a shorter bike leg here. So you actually have multiple boardings and transfers. And the second leg via bike here is obviously much quicker to take by bike than walk. So you may get a different trip planner result if you eliminated the bike here. So the point is that you're able to use your bike when it's convenient and gives you a faster end-to-end trip. So one example of it being open source and relying on open data, one of our students when we were doing this project wanted to add the USF Bull Runner, the campus shuttle. As part of our project, we focus primarily on the regional Tampa Bay area transit provider, which is Hillsborough Area Regional Transit, or HART. And we also provided data for the PSTA, which is a transit provider for the Clearwater area that's nearby the city of Tampa. So the student wanted to add Bull Runner service, so he actually put the Bull Runner service data into GTFS format, and we loaded it up in the trip planner. And this is actually an example of planning transfer from the HART service, which is bus 12 here, to the USF Bull Runner service, which is the different routes are numbered A through E. So you're transferring onto bus D for the Bull Runner solution. And this is another example where the USF Bull Runner is not on Google Transit, so they're not, Google may or may not have been interested in including the Bull Runner, but we were able to add it here in our own solution just as a demonstration that even for really small agencies, we can easily add their service to this type of open source and open data trip planner. And something else that's really unique about Open Trip Planner is the customization that you can get into when you're looking at biking trips. So we see this bike triangle here, which allows the user to drag this center circle here to the different areas of the triangle, so they can bounce things like, I want the fastest trip, I want the flattest trip for areas such as Portland that have significant altitude changes, and you may be biking up or down some really steep roads, or the quote safest or most bike-friendly trip. So the user can choose the balance here, and then the trip planner tries to adjust. And so your fastest trip may put you on more major roads, for example, than your quote most bike-friendly trip, which may end up taking some back roads. And then the safety, how safe or how bike-friendly a route is still really an open research area, and we think there's a lot of improvements that can still be made to that particular metric. And then in the area of mobile apps, so there are examples of apps out there that are actually using the Open Trip Planner source code as a back-end solution, and then they've created their own application for the front end, which is what the user actually sees. So we have two examples here: the Transit app, which actually uses OpenTripPlanner as the back-end solution, software solution for trip planning, and then Move It as well. So Move It's a little different as well from other applications, that it uses crowdsourced data. So each phone actually turns into of users turns into an AVL solution, so it can tell where buses are. And then there's other source code out there. If you want to create a new mobile app, there's some iPhone and Android source code that you could use to seed new applications. So at this point, we're going to start talking about assessing trip planning options. So I am going to turn it back over to Justin.
Thanks, Sean. So we've kind of presented, actually we have presented over the last 30 minutes, the spectrum of electronic or web-based trip planning that's in the market, been in the market going back as far as, almost as many as 10 years ago. And we feel this is pretty all-encompassing of where we were. So now, in order to take all these options and kind of make a decision about what's best for your organization or agency, we want to kind of present some pros and cons of each and where you might want to consider a certain type of system over another. I'm going to rewind now back to the first system where we talked about a proprietary or vendor furnished trip planner. These, again, were more common before the evolution of some of what Sean talked about, but it's not to say they are not completely inappropriate in every instance. So really, these are most suitable for larger agencies, major urban areas where control over the way you deliver transit information is a greater priority than the cost and effort to maintain. There's a scaling issue here that comes into play. I mean, if you are a Chicago, an RTA, particularly if you're a regional transportation organization, you have a large, multi-million population urban area combining multiple systems, you may want more control over the method of delivery of transit information that you can only get by spending, a considerably more amount of money on a proven vendor product. Again, some of the open software solutions Sean was talking about have now crept into that market. So now, that's where you look versus being totally reliant on third-party apps. You also have issues where interoperability between current and planned transit information and ways to get the information out is not a priority. So if you want a more of a closed system where you have complete control, this would be the route to go. When you're comfortable with the risk that comes with an investment in a proprietary product, where you have a very strong relationship with either a vendor or a consultant service who helps you develop these, that may be where you want something more closed, a more closed system. Again, a relationship with an existing vendor who already has products operating at your system that you can leverage to help create these. It could be a software product or a scheduling product, a CAD AVL product. And then finally, where opportunities are created to monetize the trip planner or to build a user base, a user database. Again, a lot of these instances revolve around you want more control over the system to gain more information about your users, to possibly monetize the system. In exchange, you would maintain higher costs, run the risk of technology being outdated, and also be fully responsible for maintaining a system like that. There you go, Sean. Do you want to pick that one up?
Yeah, sure. Thanks, Justin. So, so looking at our second option here, which is relying on third-party trip planners in situations where they may be preferred. As we mentioned earlier, it really allows you, by sharing open data and allowing third-party applications to use that data, you may be able to reach a large saturation in many different platforms, many different mobile platforms, and really there's going to be some solutions that pop up out there that the agency really never would have thought of, and they may evolve from particular needs that third parties see and be able to develop those types of solutions. So the third-party applications may also be appropriate when there's really just insufficient resources available to look at something like a open source trip planning solution. So at this point, it's the agency just has the resources that they have in-house in terms of manpower and is able to put their data together and share it. But beyond that, there's really no dedicated resources to look at different options for something like an open trip planning solution. And then finally, too, if you're going to rely completely on third-party applications, you're really ceding responsibility to these third-party providers for things like trip planner aesthetics, functionality, availability, usability, and development. So the agency really needs to be comfortable with that lack of control, and that any of those solutions could disappear at any given time, and the agency really has no control over anything that a third party does in terms of being forced to be able to provide a certain type of service. So we see the current scenarios for many agencies probably drift somewhere in between, where you still want to provide your data openly, but you want to start looking at these open source solutions out there, and we believe there's a large number of advantages to these. So when you're looking at an open source solution, it provides some of the advantages of the vendor-based solutions, but without some of the risks involved, such as relying on one particular vendor for that solution. So you still get the advantages of customizing the trip planner however you want, whether you do it in-house or hire an outside agency to do that for you. So this includes different features like multimodal, transit, bike, and walk within a single trip plan, and integrating things such as car and bike sharing. So again, you get full control over trip planner aesthetics, functionality, availability, usability, and development. You avoid the vendor lock-in that can come with proprietary products. And you really have the freedom of choice to choose which vendor you want to operate your trip planner, or again, you can do it in-house if you have the in-house expertise for this. And when you're looking at things like interoperability with the different transit systems, that may or may not be available with different vendor options, and there may or may not be high costs associated with those. But you know, when you have an open source solution, the integration option is always there, and you get to choose how exactly that's done and which vendor you want to go with to do that, or again, if you want to do it in-house. Open source solutions also allow for tight integration with regional entities and a desire for how the trip planner suggests transfers between these different systems. You really have you have as much control as you want over how those suggestions are provided to and the transfers are provided to the passengers. And you can also use open source trip planning to either to build information about your users and where users are planning from point A to point B, the trips around the city, or to monetize the trip planner and its accessibility. So for the open data implementation plan here, I'm going to turn it back over to Justin for the first part of this.
Okay, so now we're getting into the section of the presentation that covers how do you get from what we just discussed and these options into implementation to either being deployed versus in these third-party trip planners, or starting your own system. So I just want to lay out the context here. Is what we're about to provide, it was based on the study we mentioned earlier, the Sunrail electronic trip planning study. The recommendations for that system, as it's a system that's currently not in operation yet, and they had a pretty good time frame to get everything up and running, was that there were no internal initiatives at Sunrail to pursue its own trip planner, and funding was not available to pursue a trip planner solution for launch to self-host anything. So I just want to jump into this now, letting you know that the recommendations at the end of this were to go open data with an initial reliance on third-party apps. It's a great way to get into the marketplace, get you creating the data, while you can develop other solutions, and that's hopefully where you end up if you want more control. This is the open data implementation plan that we laid out, and it assumed, I think, about a 12-month period to get everything up and running. I will get into each of these in detail, but this is a good reference slide for organization and order of these. We're running a little tight on time, so I want to make sure we keep moving. And this plan basically breaks down into 3 categories. At the outset, the goal is to develop a policy and figure out the administration of GTFS data, which then would lead into actually creating and disseminating that data, and then closing the loop with performance monitoring and feedback. I'm going to let Sean take you through the majority of these.
Thanks, Justin. So we're going to leave some of these slides as reference. I'm just going to hit them at a high level because we're running out of time here. So really the first step is to create a policy and procedures for generating GTFS data. And so this is to look internally and see whether you want to do this in-house and how exactly the generation and maintenance process of GTFS data is going to happen. We also suggested coordinating with the regional transit providers, so Lynx and Votran for the Sunrail particular application, and to try to coordinate the release of their data and the effort of reaching out to developers so there was more of a regional consistency. And third, to draft and approve a user agreement based on existing examples. And again, we have some URLs down at the bottom here that you can visit, and some common things that are provided in these types of agreements. Then looking more at the data dissemination side. So to create a publicly accessible web address that contains your GTFS data, and there's this is a fairly common approach, and we have some existing screenshots to show one particular example here. And then to create a developer web page that links to your GTFS data and your user agreement that you've defined. And on the right here, we see an example of PSDA's developer resources that shows where their data is and how developers can get to it. Then we also suggested email blasts to notify third-party service providers, primarily via the transit developers Google Groups page. That's really one of the main lists that you want to hit, because that's has really become a global place for third-party transit application providers. So you want to let them know that your data is available. Then we also suggested to verify that your data is publicly available on the GTFS data exchange. That again is really a central clearinghouse for transit data. And your third section here is the performance monitoring and feedback. Creating an app center is one thing, for example, that many agencies have done, and we have some reference URLs down there at the bottom that you can look at to see how agencies have shared this information. And we also suggested conducting feedback surveys to see what the awareness of the apps was in the community, and to possibly reach out and if there was particular lacks of awareness in particular areas. And then we also suggested establishing an interagency trip planning technology group. So these would discuss the different plans for the future, including looking at things like an open trip planner, an open source application when the funding became available for that type of technology. And then finally, really the public awareness campaign is just to let people know that trip planners are available. That can really be accomplished through the existing communication channels with the media, but focusing primarily on this may be of benefit. So with that, we will open it up to questions, and we have the link down there for the final report, and we will make the slides available along with the webinar too for reference.
Thank you, Sean and Justin, for that presentation. Just a quick announcement that we have applied for AICP certification maintenance credit for this webcast. That's through the American Planning Association. So for all of you AICP members out there, we have applied, and you'll be notified if and when it's approved. So we do have some questions from our attendees today, Sean and Justin. The first one is, I would like to know if there are any online trip planning solutions for demand response transit service.
Yeah, I'll start on this one. That's actually a great point. If something is not schedule-based, it's typically, it leaves an automated scheduling, an automated trip planning system scratching its head, so to speak, because it doesn't know where trips start, how long trips take. Everything's kind of a custom trip rather than based on a provided schedule. But I think Sean can speak to some developments in this area, possibly where some things are going on with zones or regions.
Yeah, absolutely. As Justin said, this is kind of really something that's new in the trip planning world in terms of the overall solutions when we look at things like open data. So there is currently a effort that's starting up looking at how do we integrate demand response services into something like the GTFS specification, with the goal of eventually being able to, when agencies are publishing GTFS data, they would include things like FlexRoute or different services that may be provided that don't fit the traditional schedule-based approach. So if you're interested in that, I would suggest reaching out to me directly, and I can provide more pointers if you're interested in following the developments of that in the GTFS world.
Great, thank you. Our next question is, if a transit agency wanted to support the development of apps, what one or two things should they focus on doing?
I think some of the pointers that we had mentioned earlier is really are really key. Is providing open data. So the GTFS data would be important. If your agency has real-time data, to share that as well, to do that openly. Which really increases the odds that an application is going to pop up for your agency. And the second thing I would say is to try to create a relationship with the developer community in your particular area. So creating things like a developer site that showcases what data you have that's available to developers, trying to reach out to local universities and local meetup groups, or conducting, for example, a hackathon, which is kind of a media event that publicizes the fact that the agency's data is available for application developers to use. I think those are kind of some of the best practices, and we have some of those processes documented in the final report. And if there's any further questions too, just please contact either Justin or I, and then we'll provide you with more specific directions.
And I just wanted to state, I know we kind of plowed through those final 10 slides or so, but really within those final 10 slides, those steps, you come in somewhere into that process, and you'll see exactly what you need to do and where you need to publish data, and it really is in there. So I suggest, unfortunately, we don't have enough time to get in detail, but it's there, so you may benefit from looking at that.
Okay, great, thank you. And probably our last question, our final question, is there any known ratio of users who come into a website, for example, DART, or when TriMet had both proprietary and third-party or OS solutions, and which trip planner tools do users prefer? Is there any way to collect usage from mobile apps?
So this is Sean. I'm not aware of specific ratios. You would have to work with the mobile app developer to really find out how much traffic their particular application was getting. But I know we've talked to a couple different agencies, and TriMet being one of them, and they seem to serve different audiences. So TriMet sees it valuable to provide something like the Open Trip Planner based solution that can really targets, I think, primarily people that live in the area and familiar with TriMet as a service, but want to know how to get from point A to point B, and are interested in exactly how TriMet thinks the best way to do that is. A service like Google Transit seems to provide trip planning functionality to audiences that are more visitors that are new to the area and aren't familiar with TriMet as a provider, but are familiar with the concept of Google Maps, and know that they're kind of a central provider that with these number of different cities you can go to, you can get directions out of Google Maps. So there seem to fill different user needs and different user audiences. And I don't know, Justin, if you want to add to that.
Sorry, I was on mute there. I've not seen anything on what preferred, but I think one part of this that a lot of transit agencies are kind of stopping at least that I'm aware of, are that once you get yourself out there in the trip planner, whether it be just Google Transit or it be more than Google Transit, I'm not reading about, hearing from, or seeing much of closing that loop to really gauge your user preferences. And that, I think it was slide 8 or 9, The GoRoo product had a lot of great examples to pull from it, some good lessons learned, and one was a user survey that actually put that product up against several other products in the marketplace to ask them their preferences. And once you learn that information, it'll help you target where to focus, apps in your app center, because your users need more trips to, maybe traditional trip generators, or it could be, we need more bike and ped development in our trip planner. So, slides 8, 9, and 10 really concern this part of the process that gets feedback from the users to make improvements going forward, and it's not just driven by the community of people who create these products.
Well, thank you, Sean and Justin, both for your presentation today. We have reached the 1 hour mark, so I want to thank our audience for their attendance and participation. If you did submit a question that was not asked, I'll be sure to send that to the presenters and we'll communicate the response to all attendees. So once again, we would appreciate your feedback. The evaluation is loaded for you to complete. If you could give us your thoughts and any suggestions for future sessions, we hope to see you in another webcast. So thanks once again and have a great afternoon.